Hello, welcome back. Now we are going to see the last experiment numbers 10. We have to implement in this implementations of binary search tree. In aim to implement binary search tree algorithm, we have to see the algorithm. Usage of structures of node. Each node is tree has three fields, namely left, key, right. On step 2, usage of insert method. Insert method. Now we have to, this method requires to input address of the parent node or node to be inserted into the tree X. If R is none, create an object to node class passing X to create a new node and return node object. In this class node, define int self X. Self key is self key equal to X, self left equal to N. Now self right equal to none. In this three variable is very important. Key left to right. Now we have to see the insert r comma x. R comma x, in this having two variables r comma x. If r double equal to none, we have to see the return node x. If x r dot key, we have to see the r dot left equal to insert r dot left x. Now if x isn't r key, or right equal to insert r dot right x. Now return or define in order root. If root in order root left, print root dot key comma n equal to in order root right, define pre-order root. Now if root is root, print root key n equal to s. Now we are going to see the traversal algorithm. Left, parent, right. Now we have to consider a basic conditions. If root is not none for regressive, make a regressive call with left field of the node as parameter. Print the value of node. Now we have to print the value of node, and we have to see the define post order. If root post order, root left post order, root right. Now we have to print root key and equal to define minimum root temp equal to root. Now while temp left equal to none, temp equal to temp left. Now we have to print minimum temp key. Now we have to do the minimum temp key. Now we have to define the maximum root. In this we have to use the right value. Root equal to temp equal to root, while temp dot right equal to none. In the we have to, if we have defined maximum root, now we have to print maximum temp key. Now we have to search a root x. If root is none or root key equal to searching for parent node, the root will be searching for the parent node. Now we are going to see the same root, return root. If x root key, return search root left x, return search root right x. If root is none, then it will be print empty list. Then it will be return q equal to q and root. While n q 0, print q 0 dot key equal to node q pop. If node left is not none, q append node left. if node write is not done, q happened node write. Now we are going to see the root equal to none. Print 1 insert print 2 in order travel. Now we are going to see the find. We have to see the nine numbers of in this variable. Insert in order traveler, pre-order traveler. Now we have to see level order, post order, search, find maximum, exit. Now we have to see the true character input. Enter your choice. If character w equal to 1, data equal to input, enter the data to be insert. Now we have to put root equal to insert root comma data. Print root. If character double equal to 2, double equal to 2. Print list. In order, we have to see the numbers. We have to see the numbers and print found attempt. Else print level order root. If c double equal to 6 and print found at attempt. Else print str key plus not found in the tree. You have to see 7, 8, 9. Then break. Else print invalid input. Try again, it will become. Now we are going to see the output. In this we have to put that 9 variables. Insert in order, pre-order, post order. It should be entered your choice. And that's all about this experiment. Experiment number 10. Implementations of binary search tree. Thank you.